Welcome back. We're about to take the final step in scheduling mission using our mission control dashboard. Let's take that API that we've built and connect it to our React front end. We're going to start by going into our requests.js file in our client under source, hooks, and we're ready, just like this to-do comment here predicted. All right, so let's remove that. And what we're going to do is await the promise returned by the fetch function when we make a post request to our API with the launches collection. But remember, the fetch function defaults to the get method, just like when we get the list of all of our launches. The way we make a post request with our fetch function is by passing in this options object as the second parameter and setting the method directly to post. Now, this HTTP submit launch function takes in some data as a parameter. Let's see what's being passed in. We call this function in useLaunches.js. Below where we do our get launches, in this submit launch function that uses the use callback React hook, which basically just takes the callback function that we pass in and saves the result so it doesn't need to execute over and over when nothing has changed. And our function takes in this form data from some HTML form, and it gets the launch day from that calendar picker on our launch page. It takes in the mission name and the other two required fields, and then passes them in as an object to our HTTP submit launch function. So all we need to do in requests.js is to make sure that this launch data is passed in as the body of our fetch request, which is set with the body parameter in our object over here. We'll set the body to the launch object. Can't forget this comma here. But one of the quirks with the fetch function built into the browser is that when we pass in the body, the value we pass in needs to be a string, and launch is an object. So what we'll do is we'll call the json.stringify function to convert our object into a valid JSON string that can then be passed directly into our API. And if we're passing in JSON, we'll need to set one header in our headers object. What was the header that we needed to set? That's right, the content-type of the data that we're passing in the body, which is application/JSON. Beautiful. Our launch data is now being sent to our API. But how is our submit launch function being used? There's something we're missing. In our useLaunches.js file, notice that we're taking this response as the result of awaiting for our function call. And we have this to-do here, which is telling us that we need to set this success constant based on the result of our function call. When the success is true, we'll fetch our launches from our API, which should also return our newly scheduled mission here. And then we play this success sound and set the launch as no longer pending after a short 800 millisecond delay. So our front end is tracking the success of our request in this pending launch variable that we track as state, with the default value being false, probably to show some kind of loading spinner and play a success or an error sound, a failure sound in this case, when the request was not a success. And using this response that's returned from our function, we'll then be able to set this pending launch to false once it succeeds, which means that up here, we can uncomment the set pending launch to true, and our front end won't be stuck in a permanent state of pending, showing the user some loading spinner forever. All right, so in requests.js, we can return the result of awaiting our fetch function, which will then give us this response object that includes this response.ok property, which is set when that request comes back with one of our 200 response codes, which means we can set success to response.ok. And our to-do has been done. But not quite. You see, we're all about handling errors in this video. And there's a little quirk with the fetch function where if the entire request fails, for example, the network is down and you can't even connect to the server, or if the server rejects your request because of an issue with CORS, well, in that case, the response status code won't be set because the server isn't responding. And so, rather than this response.ok property being false, our fetch function here will throw an error. So we need to catch that error using JavaScript's try catch syntax, and we'll move our fetch call into that block. So if this await fetch call throws an error, we want to catch it, and we'll call the error error. And what do? We'll return an object that triggers our condition in useLaunches, which is response.ok being false, the success being false, and our failure sound being triggered. Back in requests.js, our object will be OK, false. That's it. Now, when an error is thrown, we'll run into the exact same logic that we would if we got back a 400 response. And our success and failure case here will execute just like we expect. Let's see what our mission control dashboard looks like when we submit a new mission to one of our Kepler planets. We're testing our production deployment, and we've updated our front-end code, so we need to run our deploy command one more time. Here we go. In the browser, let's refresh our mission control dashboard. Our upcoming page should have just the one launch from our example that we've hard-coded. And now, if we go to our launch page and schedule a launch for, say, June 15th, 2023, we'll say, hello, new Earth, using the Explorer IS-1 rocket, and we're going to Kepler-62f. Let's go! Oh boy, that sounded more like a failure than a success. We can see that our launch mission triggered, and we have this spinner that shows that we're still pending. So something didn't get set correctly. Let's see if our launch is in our upcoming page. Nothing to see here. Let's take a look at our server logs. Everything looks good. We can even see our post request to our launch's endpoint coming into our server. But we see that we got a 400 response to that request. What happened? Let's look at our launch's controller. We're accepting a mission, a rocket, a launch date, and a destination, while in our requests.js, well, everything looks fine here, but in use launches, we're passing in the launch date, the mission, the rocket, but a target rather than a destination. There's been a disagreement in how we name things between our front-end developers and our back-end. This is totally fine and often the source of healthy discussion. We'll be a good team player and say that for our purposes, both a target and destination make sense. So we'll make the change on the back end. In our launches model, we'll make sure that we're setting the target for the planet that we're aiming for. And then in our controller, we'll update launch.destination in our little validation block here, changing it to target. Now let's restart our production build by running npm run deploy. When our server is running and our front end is being served, let's refresh our browser and go to that launch page. We'll create the same launch as before. Scheduled for June 15th, Hello New Earth, and destination Kepler-62f. Let's schedule our first mission. We are go for launch. Now in our upcoming page, we should see our newly scheduled mission along with the destination exoplanets for both our example and any mission that we add. We are one step closer to exploring planets beyond our solar system. Let's keep going. I'll see you in the next video.